you. It's great to be here. So, good morning, everybody. My name is Xenofon, and today I'm excited to present our work on a simplified and modernized build system for Kamailio. This is a journey from the old complex make-based system to more maintainable, hopefully, cmake-based approach. Before we dive in, a quick word about Gilawa, our company. We specialize in real-time communication, offering management, consulting, training, and development for clients worldwide. We've been developing features and product enhancements for various open source projects, and we integrate them back to the open source community, and of course provide some technical consultancy especially around performance, availability, and security. Some of our clients are worldwide and they are mostly internet service providers and telephone providers. So let's jump to the main topic of our presentation. Kamailio build system is based currently on Make. It's a very mature and widely used build tool. But as our Kamailio project grew, the complexity of its Makefiles were a bit too much. So Make served us well, but as Kamailio grew, as I've told before, the Kamailio Makefiles grew larger with over 20 years of history and with hard-to-follow mechanics and over 500 Makefiles currently to look for. It was a time for a review, and with some minor points that also attributed to change. It was the heart of debug, lack of good IDE support, and of course the in-source builds, which clutters our source environments even more with already big code base. Also, the complex manual flag package object dependencies, and the learning curve grew even larger when more stuff went into the Kamailio Makefiles. So here is just for a demonstration, a simple thing as identifying compiler version and ID. In Makefiles, on the left, we had to have 50 or so lines, but on the new cmake, we can just do it with the cmake variables already provided and just do some brief checks. Of course, why did we choose cmake? Cmake is the de-facto standard currently for building C++ code, C and C++ code, with millions of downloads. It's a powerful tool, very comprehensive solution for managing the software build process with cross-platform support for, of course, Linux, macOS. Why not if we want to support Windows as well, with native and good IDE support in multiple dev environments like VS Code and CLion. We can produce from a single source of cmake list with various build tools like Make, Ninja, Xcode, whatever you prefer, you can choose. And of course, the multiple out-of-source builds that you can use to declutter our environment space. It includes simpler dependency management, as well as internal and external for our targets and our external library dependencies. Hopefully, also some cleaner and more descriptive error messages can appear so we can track where our problems are. So, the heart of cmake system is the cmake list.txt file. It's the analogous of a Makefile. It's the recipe used by cmake, just like Makefile. It tries to be as declarative as possible with variables and functions that are target-focused and try to define most of the properties, options, and definitions per target, so not to pollute may be external dependencies we have, or if we bring some other GitHub projects, we don't pollute their definitions and so on. It can also track the dependencies between our internal targets. We can define dependencies as well. And it can handle, of course, the building and the installation of our project. On the right, we can see some of the most widely used functions, like the add library for our modules, for example, our binaries for Kamailio, camctl, and what's on. And of course, the linkage and compile definitions are per target. Also, cmake provides us a long list of cmake variables that we can use to identify, for example, our system architecture, compiler, and so on. So for the migration, handling the migration was a bit convoluted. We have to start simple. We had to start building the core first and try to see what definitions, what sources we need, and libraries, and what sort of, and some more. Then we added some basic modules that we needed to, for example, in the basic configuration, so we can run and see and confirm that our Kamailio is running as before. And of course, we added the basic utils and tools like camctl, camdb, camdbctl, and the rest of them and their configurations. After testing with the default config and see that all is good and running, then we proceeded with adding the additional targets like documentation, utilities, DB schema generation, and man pages. While writing the migration, we had 3 concepts in mind: to be as modular as possible for reusable components, simplicity, to not get into like make was, try to keep it simple, and of course, to be more maintainable on the long run. So after our transition, now we are having a clearly defined cmake list for our core, for our modules, for our libraries. Also, cmake offers the external library and dependency handling, like find the library.cmake for finding any library we can need in our modules. We separated OS and compiler specific on their own cmake files, and of course provide the user a way to override them and adapt them as one wants. And we can, of course, easily define some already cmake provided types, like build type if we want some release, debug, or release with debug information, and of course, where we want to install our project. Of course, the cmake transition was not without its hassle. We started with a clean state with no compilation options at all to see what was really necessary. Some options, of course, you will think that it was optional, like the use _ feature, but many of them are not, like use TLS, use TCP, even statistics. You will think it's not necessary, but it is. There were some compilation problems, and that led us also to identify that the code base had a very long a maze of if-def options that one had to track, okay, this we want, this we don't want, and how to identify what's really needed to fix any problem that aroused. Another problem we found was that it was hard to track the available targets from Makefiles. I had to make some Makefile adaptations so it can print all the targets, so I can really translate all of them into cmake. And let's see a bit about more of the dev options. As I said, it was hard to track from the Makefiles and even from the available documentation online what users can choose which features they want on or off. And Of course, as I said, the combination of on and off maybe produce some other unexpected break problems. For example, if we didn't define use TCP, the first error was some variable was undeclared, but if also use SSTP it was not defined, we get the invalid defined type error. Also, the use TLS and code TLS, if you define code TLS, it tries to include some not existing folder due to some makefile definitions that probably deprecated some time ago, and also some other options that you would think one of them was required, and they are all required. But the cmake way tries to make it a bit more clear. On the left, we have the make, which options are just like variables, and you can't really know if it's just an internal variable that we are doing some checks. And on the left, we have clearly defined options with some description and their default options. This will make, hopefully, onboarding and customization much easier for us developers and probably the end users, package maintainers, and what so on. So what does this mean for us as users, developers? We get, as I said before, easier onboarding, better IDE integration with various dev tools, with syntax highlighting, IntelliSense, documentations. The config, build, and install phases are standardized, and adding our new modules is just as easy as Makefile with more easily and standardized way of providing options and definitions per target. So let's get to the good part, how to use cmake to build and install our Kamailio. Just out of curiosity, how many of you know the cmake flow, and have you used cmake at all? Okay, that's good. There are at least two distinct phases in cmake flow, and many more that one can use. The two that are really required is the configure generate phase, and of course the build phase where the actual building is happening. And then we can have some separate phases like install, where of course we install the program, and package phase where package maintainers, for example, can invoke a command and the Debian package or whatever package is ready. Just a note here, all cmake commands should be called from the root folder of Kamailio in this example. And the install phase, it's a bit tricky, does not depend on build. The cmake -- install will not automatically call the cmake -- build part. I don't know why, that's how it is. So let's dive a bit into the configure generate phase. What it actually does, it parses the top level cmake list of the source tree, and then create a cmake cache populated with various variables like the compiler, dependencies, options, feature supporting, and whatever else is needed. And then generates the appropriate build tool you choose. Like if you choose Makefiles, it will create the Makefiles. If you chose Ninja generator, it will create the Ninja appropriate build files, and so on. And in this phase, this is where we provide our definitions and various options that cmake and Kamailio cmakes provides. This is a sample command we will see in more detail in the following slides. Next comes the build phase, where cmake invokes the build tool defined earlier, whatever that is, to produce our executables, our libraries, and execute any pre and post commands described in the cmake list. Here is another sample command of how to use the build phase. It's cmake -- build, and whenever we decided that we want our build artifacts to be found. And of course, the install phase will just call the install target and copy and install the files and dictated by the cmake in the path we provided, either in cmake install prefix or in cmake -- prefix CLI. This is a more advanced feature. We currently not supported due to some hard-coded paths in our cmake list. Of course, for package maintainers and if any other use case, cmake respects desdir and variable to stage your install and make it easier for packaging. Let's get on how to use it. So this is the configuration phase, full command, for example. We need to provide our definitions and options on the configuration phase, like this way. -d is the standard. This is the way to pass any definition into cmake, and the definition name or option value equals and the value. For example, here, -s dot means where our top cmake list is, where our source is, our current folder, for example, where we want the build files to be built and produced. The --fresh is just an extra demonstration for now purposes. It's to clear any cache and recalculate any available variable. And here we have two available variables from cmake. Is cmake install prefix, where we want our installation to be placed, and what type of build we want. For example, use and debug for now. The rest are some of the options we provide as cmake. I try to keep most of them in comparison to Makefiles, like, for example, exclude modules and include modules were already there in Makefile. And what they do is what they describe. If you don't want some modules to be built, you provide the exclude modules, and include modules does exactly the opposite. We introduced also this module group name. It was not really used, I think, in the Makefiles apart from packaging, but now you can provide also a name. We have defined some groups in a separate cmake file, and it will build all the modules included in that group. For example, for all, it will build all modules available, all modules found in modules folder. We have many more. We have the defaults, which is a small part, and of course the groups of TLS and some packaging defined groups. Of course, the build doc is for building documentation and installing as well. Okay, let's try a small demo. How to add a new module is pretty straightforward. You can create a new folder under the module folder. For example, let's call it for now ACC test, doesn't matter. But remember, the name of the folder will be the name of the target as well. Of course, we have to prepare the source files, the headers, and the respective cmake list. We can add it to the group, defining groups.cmake for being inclusion in, of course, in some dedicated group if we want. And the next time cmake config phase will run, it will pick it up automatically and it will build it if it's in the included modules or in the module group name identified. Here you can see a bit of the cmake list file that will be, basically let's check it on the cmake here. Yeah, you can see it, great. So we have created, for example, in this case, we have created a simple module, new module. We have created a header folder, a header file, and a C file, and of course, its respective cmake. Here we're telling cmake to grab all of the sources found in this current folder. We add the library itself as a target. The dollar module name is provided by previously cmake defined variables, but here you can define whatever you want. It's best to keep it as module name to keep it consistent with the rest of the modules. The shared means we want it to be a shared library. There is a way, of course, in cmake to define static and shared as a whole library, or as a whole, but we didn't do this since all of our modules have to be shared, not static. Then we can define some fine packages to declare our dependencies on our modules. If a library does not support directly cmake but supports package config, for example, we can also use this mechanism. What we do is find package config. We say we need to have this library called Xenofon. This is just for easier and more standard way of providing the linkage. We just alias the target to another name. For example, if we need OpenSSL, which is already providing the find package, we can do it like this. Find package, we require OpenSSL. And then we link our module with these three targets: Xenofon, OpenSSL, and crypto. Of course, we can provide per target extra definitions and flags and another with values or whatever. And of course, we can define if we want another C standard to have per target as well. Okay, let's see it in action. First, we have to provide the configuration phase. So here it is. We provide the already provided as before variables. We have to include it in the include modules. You see here I also put the name of the module because I didn't include it in any group for now. We can run it. It can produce, we can see here a lot of information, what definitions we are already having, some compiler options, some installed directories, and so on. And also a warning here that it didn't found any documentation because we didn't include the doc folder inside. It's just a warning that lets you know that something is missing. Also here we see that found OpenSSL was found in our system, and also the Xenofon library, and all is ready now for compilation. We run the cmake -- build. We can provide also -j for multi-threaded building. -- clean first, it cleans everything and then rebuilds for more thorough, for example, let's say, way, and verbose to be verbose, to have all information printed out. So you can see now it starts building with verbose information. This now builds the core, and we are done. And a note here that we can see about extra flag, if we can search. Come on. Can't find it right now, sorry. I wanted to show the extra flags that provided were included in our target. But yeah, I will do it maybe if we have some time left afterwards. So let's continue. Also I forgot to, if we do install, it will install our files in our previously defined install path. So that's it for our demo. So some future work that we might want to do is, of course, implement any missing targets from the old Makefiles. Please, if you find something that is not implemented yet, please ping me up. Add packaging using cpack, another tool that cmake provides. We are, I think, almost there, but still have to do some testing. There is some new thing that cmake provides, the cmake presets. It's just a nice way to provide the default configuration of maybe for Linux, maybe for macOS, what you should not compile because it's not really available, and so on. Adopt for cross compilation. I don't know if this is really needed, but we can adopt this. And of course, add any missing information from our for our cmake. You can find a lot of these things on our tutorials page. We have a lot of we have a tutorial which covers every options we provide to the user, and the right one is the cmake documentation for more information. That's it. Thank you for your attention. If you have any questions, please.
Thank you, Xenofon, for your help bringing us up to date, because the all Makefiles were getting really, really complex. Tyler?
Thanks for the talk. It was great. I was wondering about the documentation generation. Is that like built into cmake? Because we had the
yes. There was targets on Makefile as well. So I just translated and used some modern the cmake way to generate those as well. Yeah.
Okay. Interesting.
You can find the information about doc generation as well on the tutorial.
To give a bit more background, the documentation, it's in some XML format, docbook format, and then we generate text or HTML for the web. So that's about. You can create per module documentation, and every module and every documentation found with separate targets. Any question? One more eventually.
We have an online question.
Oh, nice.
So people are awake somewhere else as well. Is there a shell script that will call cmake with some predefined value of included or excluded modules, etc.? We don't provide one, but hopefully cmake presets will do this job if we want to implement it. Yeah.
But we have, you can provide the list of modules.
Yeah, but this provides a default, okay, I want for Linux, I want to build, this includes modules, and these exclude modules, don't build them because they are not found in the distribution.
Okay.
Yep.
Thank you, Xenofon.
Thank you.
He's going to be around all day, more or less. So.